Hi, in this video we're going to look at answering the question 5 on practice paper 2, which has been designed for AQA Core 1, but it's suitable for other examples too. For more information you can contact me on Twitter at Mr_G_Walton or ask on our school account at Tupton Maths. So question 5 is asking about a straight line L1 and it's passing through 2 points, A with the coordinates -2, 5 and the point B with coordinates 4, 1. First of all, we're asked to find an equation for L1 and put it in a particular form where A, B and C are integers. Okay, before we do anything else, we're going to draw ourselves a small sketch so we can see what's going on. So again, this doesn't have to be accurate, but it just has to give you a rough idea so we can see what in fact it is that we're playing with. You might be able to do this just algebraically, but even if you can, I'd always recommend a sketch in case you end up going wrong. So point A is -2, so that's -2 along here, 5 up. So here's point A, and let's just mark on the coordinates, -2, 5. Point B is at 4, 1, so that's going to be somewhere down here. So let's call this B, and that's 4, 1. Okay, now the first thing it asks is to find an equation of the line between these 2 points. Okay, if I'm trying to find an equation of a line between these 2 points, what I'm particularly interested in is the gradient and then one of the coordinates, because then we can use y minus y1 equals mx minus x1. I've been given 2 coordinates straight away, so I can use either of those. I'm pretty sure I'm going to go with this one because it hasn't got any negatives in it. It just makes my life a little bit easier. But what I need to work out is the gradient. I can do that quite straightforward. We need to work out the change in y divided by the change in x. So let's just have a little look. The change in y, well, my y coordinates have gone from 1 up to 5. So that's got to change. If we're thinking about it in terms of going from A to B, it's gone down 4. What's happening along the x-axis? Well, I've gone from -2 all the way along to 4. So that has a change of 6. So we're remembering that m is my change in y divided by my change in x. Excuse me. Which in this case is -4 over 6, or we can simplify that further to -2/3. So I've worked out my gradient. Let's do this then. So we've got y minus, let's pick one of the values. I'm definitely going to go with B. The y coordinate here is 1. It wouldn't actually matter. We could do exactly the same and get exactly the same answer from A. I just prefer to use this one because it's got all positive values. Equals, what was I, m was -2/3, x minus 4. Now at this point I'm going to multiply everything by 3. That's going to tidy up this side no end. So multiplying this side by 3, I'm going to get 3y minus 3 equals -2 lots of x minus 4. This is possibly the line, if you were going to make a mistake anywhere, it would be going from this line to this line, or maybe not going from that line to that line is possibly where you're going to make any errors. Let's tidy up now. I can expand brackets, collect like terms, and get it into the relevant form. This is not doing anything particularly difficult at this point now, I don't think. It wants it ax plus by equals c, so let's get all my x's onto one side with my y's and my values on the other side. So adding 2x to both sides is going to give me 2x plus 3y equals, and then if I add 3 to both sides, I'm going to get 11. 2x plus 3y equals 11 is the equation of my line L1. So this is L1. Done. Okay, let's move on to the next part of the question then. Part B says the straight line L2 passes through the point B and it's perpendicular to L1. Well, we remembered that the gradient m, we'll call it m1 at this point, we remember that that was -2/3. So if we're finding the gradient of something that's perpendicular to it, we remember that m1 multiplied by m2 gives us a value of minus 1. Okay, so we've got minus 2/3 here. What we're going to do is work out what m2 is. And again, you will have seen on several occasions before that you take the negative reciprocal of this value. Okay, so these two things multiply together to give me minus 1. m2 is 3/2. Okay, now we also know that it passes through the point B, and the point B on our question was going through 4, 1. So again, I've now got enough information with a point and the gradient to be able to use y minus y1 equals mx minus x1. So y minus 1 equals 3/2 x minus 4. Let's multiply everything up again to keep it tidy. So I'm multiplying everything by 2 first of all. Now, although it doesn't actually say what form, so this is an interesting point at this point. If you're confident at doing the next steps and multiplying it up and just keeping it a bit more tidy, then by all means do so. However, you've actually got an equation of a line for L2 here. In this form, you don't actually need to do anything unless it says so. So you could just stop there. I'm not going to. I'm actually going to just tidy it up because it might be useful to us later. So let's multiply everything by 2. 2y minus 2 equals 3 lots of x minus 4. 2y minus 2 equals 3x minus 12. And again, let's just get it in one kind of form. So I'm going to bring, what's the easiest way to do this? If I take 2y across to the right, so take 2y from both sides and add 12 to both sides, then I end up with minus 2 equals 3x. Let's just do it in a space where we can actually do it properly. We've got, what was I doing? I was taking 2x away from both sides. So minus 2 equals 3x minus 12 minus 2y, and add 12 to both sides. So 10 equals 3x minus 2y. Okay, that's fairly neat and tidy, but like I said before, that is perfectly fine for this question. Okay. The final thing says, given that L2 meets the y-axis at the point C, show that the triangle ABC is isosceles. So before I do anything else, I'm just going to draw myself a quick sketch again. Let's see if we can get these values back on. So we said that A was at minus 2. Here's A, and it was at minus 2, 5. We had B over here somewhere, which we said was at 4, 1. This was B. And we're now told that this line that went through this, we've now found another line perpendicular to it. So at right angles here, as we've got another point down here, which is C. And what we're being asked to do is to work out whether this is an isosceles triangle or not. Now, for this to be an isosceles triangle, there's going to have to be two sides that are the same length, and the base angle is going to have to be the same. Now, we've already determined that this line and this line, this was L1 if we remember, so this line is L1. This line down here was L2, and we've decided that they're perpendicular to each other. So I've already naturally just drawn in a right angle. That means that this here can't be a right angle. Otherwise my line would be coming like this, and it wouldn't make a triangle at all. L1 and this new line would be parallel to each other, so that wouldn't make a triangle. So the only two lines that could be the case to make this isosceles would be these two lines here. Now we're going to have to work out the lengths of the lines to show that they're isosceles. I've already got enough coordinates here to work out the length of the line, but what I don't have are the coordinates down here? I know one of the coordinates is 0, because it's along the x-axis, the y-axis, sorry, where x is 0. What I don't know yet is the y coordinate. So let's see. The equation of this line L2 excuse me, was 3x minus 2y equals 10. Now if x is 0, then minus 2y equals 10, which means that y is minus 5. So this point down here is minus 5. So what we're going to have to work out is the length of the two lines, L1 and L2, between the coordinates given. So let's do L1 first. Let's do it over here. This was just an aside, I'll leave that there. So L1, to work out the length of the line, remember we're going to use our friend Pythagoras. We've got, again, enough information to be able to do this. We remember before that when we were working out the gradient that the height of this right angled triangle here went from 1 up to 5, it was 4, and along the bottom it was 6. So we're going to do the square root of 4 squared plus 6 squared, which is going to be 16 plus 36, root 52. If I've worked that out right, hopefully I have. 16 plus 36, yeah, 52, root 52. So the length of L1 is root 52. If the length of L2 is also root 52, then we've shown that these two lines are the same length, so therefore ABC is isosceles. Okay, let's see if we can do this then. Let's work out some values. Again, we've got a right angle. We're going from 0 all the way across to 1, which is 4 here, and we're going minus 5 up to 1, which is 6. In fact, we've got exactly the same values. Look, we've got root 4 squared plus 6 squared, which again is root 52. L1 equals L2, therefore ABC has a pair of equal sides, therefore ABC is isosceles. Fantastic. It's always worth putting down the explanation of why you think it's isosceles. It does in fact say show that. So I've done some maths. It's not enough to stop at this point here this time. You must have a line that then explains why you've done the maths that you've done. Okay, it's very straightforward. In your head you've been doing it. Just make sure you've written it down as well. And do it neater than I have. Okay, so as ever, when we're doing these videos, I like to do a revision card session at the end. When we're doing coordinate geometry, always draw yourself a small sketch to help you minimise any mistakes that you might make with your algebra. Make sure that you read the question carefully. Make sure if it says parallel, we're doing things that are parallel. If it's perpendicular, or if it's a tangent and a normal, don't mix these things up. Go back after you've done the maths and read what the question says. Make sure you're actually answering it. It only takes another couple of seconds just to make sure that you've read the question and you've answered the question properly. And as ever, whenever you're drawing things out, keep sight of what it is that you're doing. Try to kind of visualise it. I think you'll find it so much easier if you're able to visualise what it is that the maths is leading you towards. Okay, as ever, good luck with any exams, and if you need anything, get in touch. Bye.